Hey, good morning, everyone. Don Gillis from Emerson. I'm in Sydney, Ohio at the Copeland plant. I work for Educational Services, as most of you hopefully know. Hey, listen, I want to talk about superheat today. And I know a lot of folks talk about superheat and we all understand superheat, but I want to point out some small little details in some of our AE bulletins that you may or may not already know, okay? Kind of explain that a little bit. But before I do, I was missing this little washer last week when I was talking about discharge ports that are mounted on the Copeland scroll and how they work. Okay, so that washer would be in there. This disc would be like so. Discharge gas tries to re-enter upon shutdown. That washer then blocks those holes that are on the outside of that. Okay, and doesn't allow that. And there's all different types and shapes and different styles. And I had ordered these before last week's little Fun Fact Friday, and they just arrived shortly after. So thanks to everyone that helped me out with these, by the way. These are the kind of things that we pass around the classroom on our instructor-led courses, by the way, and that's what I'm getting them for. Okay, so this would be the lower temperature stuff that has a spring actually in it that pushes it back by itself. All right, only allows it to go so far open. All right, and there's different shapes and sizes for all of them. Okay. But enough of that. Let's talk about what I really wanted to talk about today. I just want to make sure you kind of saw my little goodies before I put them in my parts box for the year coming up. So let me share my screen. All right. And I want to talk about superheat. This is actually just something I had already prepared for something I'm going to be delivering tomorrow. Let me grab a laser here real quick. Like I said, I apologize for not having my face on the screen or the webcam going. That might be a good thing, though. So I want to talk about AE 4-1299 revision 21. This is one of our AE bulletins, and you can find that on our app, AE app, all right, which is in our app store. It is free. Look these kind of things up, okay? So this is just a diagram. We all understand it. You know, you've got two different superheats. You've got your superheat leaving the evaporator, which is usually, what the OEM is looking for or the system designer. And then we have total superheat, which is entering the compressor, which is something like Copeland or Emerson would be asking if you run tech support for them. Notice we're using 404A as the example, 16 PSIG on the gauge, which is the equivalent on the saturation pressure temperature chart at -20. We're taking our temperature reading within 6 inches of our gauges if possible, subtracting the two. The moral of this story is we have 20 degrees superheat, okay? Emerson doesn't really dictate superheat or subcooling. I get that all the time in the classroom. What's Emerson want for superheat? What do we want for subcooling? Well, we really don't dictate that, to be honest with you. But we suggest in some situations when uncontrollable liquid flood back is a situation, we will recommend a 20 degrees superheat at the compressor in a high load condition. Okay, for the fact that if we set it for a minimum of 20-degree superheat in high load condition, we feel comfortable in saying we're going to have some superheat. And those low temperatures of the night, 1 o'clock in the morning, whatever that looks like to you, it might only be 2 degrees, it might be 4 degrees, but you'll have something, okay? So in 20 degrees. But obviously that's not sketched in stone because if we had 20 degrees superheat entering a compressor, let's say in certain applications with R22, we would be smoking that compressor, okay? So be careful of how you read those things, all right? So let's take a look at this. Again, I put the A bulletin up here. I highlighted it. And this information can actually be found in multiple AE bulletins. This was just one I picked out. Okay. In order to assure that liquid refrigerant does not return to the compressor during the running cycle, attention must be given to maintaining proper superheat at the compressor suction inlet. Emerson recommends a minimum of 20 degrees Fahrenheit or 11 degrees Celsius superheat, measured on the suction line 6 inches from the suction valve to prevent liquid refrigerant flood back. Again, this is not sketched in stone. This will depend on the application. And again, We're talking about if you have uncontrollable liquid flood back and you can't control it and you've tried everything, and I'm talking about you put traps in, where that maybe they weren't before. You've added an accumulator. You've confirmed that the refrigerant lines are sized properly, as silly as that sounds. Okay. But here's what I really want to point out to you that I don't see much talked about out there with technicians. I like pointing this out in the classroom. Another method to determine if liquid refrigerant is returning to the compressor is to accurately measure the temperature difference between the compressor oil crankcase and the suction line. Okay. During continuous operation, we recommend that this difference be a minimum of 50°F or 27°C. This crankcase differential temperature requirement supersedes the minimum suction superheat requirement in the last paragraph. Okay, it supersedes it. To measure oil temperature through the compressor shell, place a thermocouple in the bottom center, not on the side, of the compressor shell and insulate from the ambient. Okay. During rapid system changes such as a defrost or ice harvest cycles, which is common, obviously, this temperature difference may drop rapidly for a short period of time. When the crankcase temperature difference falls below the recommended 50°F, our recommendation, Emerson that is the duration should not exceed a maximum time period of 2 minutes and should not go lower than 25°F or a 14°C difference. Okay. That's what I wanted to share with you today on our Fun Fact Friday. Again, I know we all talk about superheat and those kind of things, but I thought it was important to point out the some little tidbits there for you that you may or may not know. So that's all I have for you today. I'm Don Gillis with Emerson. If you're on call, be safe. Okay, we've got a long weekend in front of us for those of you that are in the States. Again, thanks for tuning in. I will see you next week. Take care, everybody. Share the knowledge and make it a great day. Thanks a lot. Bye.